Hello all, let's start chapter 3. Chapter 3, the first section is 3.1 Quadratic Functions. I know before we discussed quadratic functions, but in this chapter, in this section, we discuss quadratic functions more in detail. Um, It means we more focus on the graph of quadratic functions. What the graph means, what is the standard form of quadratic functions, what is the general form of quadratic functions, if a standard form is given, how to graph, if a general form is given, how to graph a quadratic function. Correct? Let's start with a little bit review of quadratic functions. Any function that's in the form of f of x equals ax squared plus bx plus c, we call it a quadratic function. Definitely a cannot be what? 0. Because if a becomes 0, it means it's not quadratic anymore. It means it becomes a linear equation. Correct? Now, the simple form of quadratic function, or the one that I used in the table of functions, is f of x equals x squared, correct? And even we graph this f of x equal x squared can have two types of the graphs that I want to discuss it here with you, and I want to explain something in those graphs for you, correct? Let's graph them. The graph of a quadratic function is usually a parabola. Parabola means almost a U shape, correct? The graph can open upward like this, or the graph can open downward, correct? Let me graph another one here for you. If this is coordinate system, x and y, for example, let's graph this one here, for example. Your parabola can open downward, correct? Like this. And you know, the parabola can move anywhere because we already discussed shifting, right? But here we discuss shifting in a different way. Now, both shapes are U-shape, correct? One of them is opening upward, the other one is opening downward. Now, and both of them are the functions f of x equals ax squared plus bx plus c. That's the graph for both of them. If, when the graph of f of x, or when your graph is opening upward, when your a is greater than 0, a, we call it the leading coefficient. In your book, in this part, in 3.1, even they are not calling it the leading coefficient, but soon in 3.2, they will introduce a, or a sub n, as a leading coefficient. Your a, which is the coefficient of x squared in a simple language, if it's a positive number, always the graph opens upward. And if a is less than 0, it means if the coefficient of x squared is a negative number, in this case, your parabola opens downward. Correct? Few more things. If your parabola opens upward, we already studied maximum and minimum of a function, correct? If your parabola opens upward, it means your quadratic function has a minimum point, correct? And we call this minimum point or the turning point. We call it the turning point. It has a special name, which we call it what? Vertex. The vertex of a parabola is the turning point. And that point can be a minimum point, or in this case, which a is less than 0, in this case, it can be a maximum point. You may ask me why we are studying this. Minimum point, maximum point, parabola. What can I do with this? Soon in this section, at the end of this section, I'll do some word problems for you. We call it in calculus maximization and minimization of a function. Here we don't give you that name, but at least I will show it to you that you can find the maximum and minimum of a function. Correct? One more thing. You see in this function, I draw here a dashed line which passes from the vertex. We call this dashed line axis of symmetry. Here in the first graph, your y-axis is actually the axis of symmetry. Axis of symmetry is a line that passes from the vertex, and if you see the two sides of the graph based on this line, they are symmetric to each other. Correct? These are the basic information about a quadratic function. Few things to remember. General form, f of x equals ax squared plus bx plus c. That's a quadratic function. If a is greater than 0, the coefficient of x squared. If it's greater than 0, the graph opens upward. If a is less than 0, it means the coefficient of x squared negative, the graph opens downward. The shape of the graph is parabola. If the graph opens upward, your graph has a minimum point, which we call it the vertex anyway. And if the graph opens downward, your graph has a maximum point, which is again the vertex. What is vertex? Vertex is the turning point. And the next information, axis of symmetry. Axis of symmetry always is a vertical line that passes from the vertex. Correct? Now, let's start talking about a standard form of a quadratic function. The standard form of quadratic function. Look, in the section in chapter 2, we talk about transformation or shifting, correct? If I see or if I talk about f of x equal x squared, in that section I told you that if you add a number c or if you subtract a number c from the function is moving up and down. Correct? If I show it in a graph for you to again review, if this is f of x equal x squared, the red graph, this is f of x equals x squared. For example, this graph, the green one, will be f of x equals x squared plus c. C unit, you shift your graph C unit up. Or same way, you can shift C unit down. Correct? Also, we discussed if I have f of x equals x squared, and if I do this, f of x equals x plus c or minus c squared, the graph shifts to the right or the graph shifts to the left. Correct? Now, putting these two information together, just we change the name of C here. For the horizontal shift, we use H. For vertical shift, instead of C, we use K. Correct? Then, if I put both shifts together, it will be f of x equals, let's put even an a here for you, which is the coefficient of x squared, x minus h squared plus k. Correct? When a is definitely cannot be 0, we call this form the standard form of a quadratic function. H and k, h is your horizontal shift, k is your vertical shift. Correct? Now, in this standard form, let me introduce or talk about each letter that you see in this form. What is the job of A, or what is A? What is the job of H? What is the job of K? Correct? Let me introduce all of them for you here. Let's start with A. A can tell you that if the graph opens upward or if the graph opens downward. Correct? It means if A is greater than 0, which we already discussed, if A is greater than 0, your graph always opens upward. If A is less than 0, your graph opens always what? Downward. Where is the vertex? Your vertex, you can read, is always H and K. These two numbers are showing the vertex for you. Where is the vertex of parabola? If the function is given in a standard form, immediately you see where is the vertex. The vertex is always H and K. But remember, choose the sign for H, always opposite. And choose the sign of K, always the same. What does it mean? If I show it in numeric example for you. F of x equals, let's say, 2 parentheses x minus 5 squared plus 6. If I ask you, where is the vertex? The vertex is, I'll choose the sign of h. This number is your h, and this number is your k. I'll choose opposite sign for h. It means 5. And same sign for the k, 5 and 6. I'll say, oh, the vertex of this function is at 5, 6. Correct? Now, you see the value of h is actually x, right? H represents x. Then x equal h is always your axis of symmetry. If someone asks you, where is the axis of symmetry of this function? For example, in this numeric example that I have here, where is the axis of symmetry of this function? The axis of symmetry is x equal 5 because h is 5. Okay? It means your vertical line is passing from x equal 5. Correct? These information gives you a lot, makes your life easy to graph a quadratic function. You are lucky if the function is given in a standard form to you, because you know where is the vertex, correct? Easily you know where is the axis of symmetry, and by plotting few more points, easily you can graph a quadratic function. Even you know if the function is opening upward or downward. Correct? Now, let's start slowly graphing of quadratic functions in a standard form. Correct? We graph quadratic functions if they are given in what? Standard form. In your book, they only show one method to graph a quadratic function if it's given in a standard form. I'm not saying it's wrong, it's really a good method, but there is another easy method also that I want to show it for you. Correct? Let's put first here a topic. Graphing of quadratic function and standard form. It means when it's given in the form of f of x equals ax minus h squared plus k, I want to graph these functions. Correct? Method 1, my method, the easy method. Method 1. When they give you the function in standard form, immediately identify the vertex. Where is the vertex? And after that, use a table. And after that, easily you can graph your function. Correct? Look how. I'll do an example. For example, f of x equals, let's say, x plus 2 squared minus 3. They're asking you to graph this function. Few things that I should know. How much is a? In this function, your a is outside, right? Your a is what? 1. A is greater than 0 because it's a positive one. I know definitely my function opens upward. The most important information that I need is the vertex. Where is the vertex? Opposite h, which is negative 2, and same k, negative 3. If I know this much, easily I can graph. Look, I'll draw a table of values here for me. Here I'll put x, here I'll put y, at least 5 points. Now focus what I'm telling you here. Always write your vertex in the middle like this. Here is your vertex. -2, -3. That's your vertex. Now choose few numbers greater than -2 and few numbers less than -2. Correct? If here is -2, I can choose here -1 because -1 is greater than -2. And here I can choose what? 0. You see, I can jump. I can immediately choose -2, 0, 1. But I went in a kind of order, right? If you see between -2 and -1, the difference is 1. Here, choose the same way. What is less than -2? After -2 comes -3 and negative what? 4. Put them in order. I'll show you another example and I'll later explain why, correct? Why you should do this. Look, xy. You can choose also your values like this. Vertex here, -2 and -3. I can choose here 0 and 1. Look at the number line. If this is -2, here is -1, you choose 0. Then on this side, I will not use -3, I will use -4. Because look at this distance, should be equal to this distance. I will choose here -4, and next one, what? I choose 1, -5. Correct? The easy way is this order. Use this order. Correct? That's the easy way. Now, plug in only this two value, only this two, to your function. You don't need to plug all 4. Plug in only 2 of them. Look, your function is f of x equals x plus 2 squared minus 3. Actually, I'm looking now for f of 0, right? If I plug 0. F of 0 equals 0 plus 2 squared minus 3, which gives you 2 squared 4 minus 3, which gives you 1. Correct? F 0, it becomes 1. Immediately I can tell you, if you plug in -4, -4 also gives you 1. No doubt. If you plug 0, it gives you 1. If you plug -4, it gives you 1 again. Why? Because look, -2 and 3 was your vertex. And here you have the axis of symmetry. Any 2 points around the axis of symmetry, they should have the same y. Correct? It means this one and this one is always symmetric with each other. This value and this value. Now, plug in -1. F of -1 equals -1 plus 2 squared minus 3. -1 plus 2 gives you 1. 1 squared is 1. Minus 3, which gives you what? -2. If this point is -2, immediately this point is -2. It means these 2 points are symmetric with each other. Around the vertex, any 2 points on 2 sides of the vertex, they are symmetric to each other. Right? Now you have 5 points. Can you graph it? Of course, the graph is really easy, correct? But this is just a graph. You don't have information about x-intercept and y-intercept. That's why in your book, they don't want to show this way for you. Okay? they're talking about x and y intercept. That soon I'll do that one also for you. But only for graphing, let's use our table and graph. Vertex -2, -3. X -1, -2, y -3. 1, 2, 3. -2 and 3 is here. This is your vertex. Draw the axis of symmetry here. Your vertical line passes from -2 and 3. Now, when x is 0, y is 1. x0, y1 is this point. When x is -1, y is negative what? -2. -1 and -2, this point. When x is -3, y is -2. -3 and -2 will be this point. And -4 and 1. -4 and 1 is this point. Easily you can graph your function. Because the two sides, my graph is really a bad graph. Correct? Because the two sides around the axis of symmetry is symmetric. Then it's really easy to can graph a quadratic function. Correct? But in this function only I can see the y-intercept is easy to read, which is 0, 1, the y-intercept. I cannot even read the x-intercept because it's the graph is passing from somewhere and I don't know where is the x-intercept. Correct? This is the easiest method that they may introduce this method for you in intermediate algebra. I just do one example in this method because I just showed for you how to do a graphing. Now I'll go back to your book and introduce to you the actual method that they discuss in your book, how to graph a quadratic function in a standard form. Correct? In step 1, they give you 5 steps. Step 1, always determine if the parabola opens upward or downward. It means always check if a is greater than 0 or if a is less than 0. It means the parabola opens upward and downward. Check that one. Step 2. In step 2, find the vertex, which is h and k. Correct? Step 3. In step 3, find the x-intercept of the graph. To find the x-intercept, it means put your function equal to 0, right? If you don't remember, I'm telling you here. Every time that you want to find the x-intercept of a function, it means make your function equal to 0. You can find the x, solve that equation, you can find the x-intercepts. Correct? Step 4, find the y-intercept. To find y-intercept, it means put x equal to 0, or in very good language, find always f of 0. How much is f of 0? It means plug in wherever you have x, plug it 0. It gives you the y-intercept. And step 5, plot. Plot the points and graph. Correct? Now, I'll do few examples here for you to show how to graph a quadratic function if it's given in a standard form by using this method, 5-step method. Correct? Example number 1. F of x equals -2 parentheses x minus 3 squared plus 8. They are asking you to graph this function. What was step 1? Step 1, check if a is greater than 0 or less than 0. How much is my a in this function? Your a is this number, right? Look, your general form was f of x equals a x minus h squared plus k. If you remember the general form, it's really easy to identify. How much is a? A is negative 2, and negative 2 is immediately less than 0, correct? If it's less than 0, immediately I can say the graph opens downward. Even I can say the graph has a maximum point because it's open downward. But how much is that maximum point? I don't know. Later I'll teach you how to find that value there, correct? Step 2. And step 2, identify the vertex, correct? What is my vertex in this function? Opposite h. Again, look, this is your h and this is your k, the green letters that I put there. Opposite h, it means 3. Opposite of negative 3 is 3. And same k, it means positive 8. That's your vertex, 3 and 8. Step 3, find the x-intercept. Here, do this. Write your function, only the right side of the function. Don't put f of x. Negative 2, parentheses, x minus 3 plus 8 equal what? 0. Make it equal to 0. I told you, put f of x equals 0. It means put your function f of equal to 0. And solve. Here you have a square. Correct? Let's solve it. First thing to do, subtract 8 from both sides. Correct? Then negative 2, parentheses x minus 3 all square equals negative 8. Now divide both sides by what? By negative 2. Then you can write x minus 3 squared equals positive 4. You see, before we solve these types of quadratic functions, I will use the square root property to solve this equation, right? It's the easiest way. The square root of x minus 3 all square equals plus minus the square root of 4. Here these two cancels out. X minus 3 equals plus minus what? 2. Square root of 4 is 2. Now add 3 to both sides. It means x equals 3 plus 2. One of the answers, and x equals 3 minus 2, the other answer. 3 plus 2 gives you 5. 3 minus 2 gives you 1. Now, where are the x-intercepts? The x-intercept, I told you before, in x-intercept, x has a value, y is always 0. Because of that, you see here, you made it equal to 0. What is this 0? This 0 is actually your y, correct? Then the x-intercept is at 5, 0 and 1, what? 0. These are your x-intercepts. Step 4, y-intercept. The function, again I'll write my function. F of x equals negative 2 parentheses x minus 3 all squared plus 8. I want to find the y-intercept. I told you to find the y-intercept. Look always for f of 0. It means wherever you have x on the right side, plug it 0. Then this one will be negative 2 parentheses 0 minus 3 squared plus 8. F of 0 equals negative 2 times 0 minus 3 gives you negative 3. Negative 3 squared plus 8. I'll show all the steps for you, correct? It's equal negative 2 times negative 3 squared gives you positive 9 plus 8. Negative 2 times 9 gives you negative 18 plus 8, which gives you what? Negative 18 plus 8 gives you negative 10. Then where is the y-intercept? The y-intercept is, how much is x? X is 0 because you plug in 0, and y is what? Negative 10. Now look, a lot of information. I have a lot of points. What are the list of my points? Look, the first one, the easy one, vertex, which was at 3 and 8, right? It's one order pair. X-intercept that I found for you, what was the x-intercept? 5 and 1? 1, 0 and 5, 0. It's another 2 point that you can plot. Y-intercept, which we just find the y-intercept, and it's what, 0, negative 10. Can I plot all these points and easily draw my graph? How many points I have? 1, 2, 3, 4. 4 points. And I know my graph is symmetric, right? It's then easy to graph the parabola. Let's graph it. Oh, this number is too big, negative 10. Let me do this. You can see most part of the graph. Okay, I know the graph opens downward. I'll put the x-axis a little bit high like this. Because I know my graph is opening downward. I found it at the beginning, right? Y, x. First thing to plot, 3, 4. When x is 3, y is 4. 1, 2, 3, y 4. 1, 2, 3, 4. This point. That's your vertex. Now, x-intercept 1, 0, x1, y0. This is the x-intercept, the red point. And 5, 0, 3, 4, 5, this point. These are the x-intercepts. Always I told you that draw the axis of symmetry from the vertex, correct? Wherever the vertex is, draw a dash of, my hands are shaking. Here, wherever the vertex is, draw a dash, vertical dash line from the vertex like this. Now, even if you don't find the y-intercept, you know that's the shape. At least you know now the shape of the graph is like this. The graph is passing from this and turning here at the vertex, going back down here. Correct? But you have another point, which is 0, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This point. Actually, the graph is opening too narrow. Aha, I couldn't graph it. Let me clean this part. It's so difficult. It should be a nice shape of parabola passing from this point, correct? And also same way here. That is your graph and that's your vertex, which is 3 and 4. you have a nice graph on page 348 for this example, correct? Page 348, because my graph with this electric pen so difficult to graph, correct? This is how you graph a quadratic function. It's again a review, correct? 5 steps. Step 1, identify if the a is greater than 0 or less than 0. It means identify if your graph is opening upward, downward. Why you are doing this? Because sometimes we do mistake. We put in wrong numbers, and instead of opening downward, we graph it upward. The easy way to understand that you did a mistake or not, look at to A. A tells you if you did a mistake or not. Correct? I'll stop this part of the lecture here. In the second part of this video, I'll use the general form of a quadratic function and how to graph using general form. I'll explain it in the second part of the video. I'll stop here the lecture and see you all in the second part of this video.